Hi students, how are you? Today we are going to discuss on the quantification of elements, unit number 7, grade 10. So under this unit, you know that we are going to talk about the moles and Avogadro constant. Can you measure the mass of an atom or a molecule using your home scale or any equipments found in your lab? Think about it. So, these atoms are very tiny particles where you cannot see it by your naked eye, and there is no any such equipments even to see an atom. Then, how can you measure it? So, when you look at atoms, so these elements, the mass of a hydrogen, if you look at mass of a hydrogen, it is very, very less, very small number of grams. So, generally, you can observe the mass of a hydrogen is 0.00, around 20 zeros around, right? 20 zeros, 1674 grams. So there are no any such devices that you can measure these tiny particles, which the grams are in 10 to the power minus 24. So in such a case, what we do is we will try to come up with a concept called relativity or relatively, or we compare using a standard atom. So what is the concept we talk here? It is on relative mass. We will come up with a concept called relative mass. For an example, to understand the word relative mass or the relativity, you can observe certain objects or the balls. We take examples as balls with different masses, different sizes are shown here. If I ask you to measure, right, or weigh these objects, when you don't find a scale, can you measure it? How do you measure? That is what we are trying to do. So in such a case, when there are no scales to measure, what you can do is select out of these balls or select an object out of these available objects or the balls, for example, as a standard ball or standard mass unit. So what I'm going to select here, as you can see, the blue ball as the standard mass unit. So what I'm going to do now, I'm going to compare the standard ball with the other balls. So I'm going to compare with the other balls relative to the standard ball which I selected. How many times the other balls are bigger or smaller? So now you see we can get an idea here. So if you look at these the colors of balls, the number of times that they are bigger or smaller can be observed. So just you can approximately get an idea of their mass. So in case of atoms or molecules, so we are going to come up with such relative concept. So we have to select a standard atom, and based on that atom, we are going to compare with the other elements and compounds. Before we learn about this, I just wanted to explain you the subatomic particles that are found in an atom. So you know that the protons and neutrons are accumulated in the middle, the electrons are revolving around it. So when you compare the protons and neutrons, generally they are equal in mass and the size. Mass of a proton is equal to the mass of a neutron. But if you look at the mass of an electron, can you guess? And what do you think about the mass of an electron compared with proton and a neutron? So generally, remember, the electrons are 1840 times smaller than a proton or neutron. So that means that much of very tiny. So when we measure the mass of elements or molecules, we don't take electrons as a contributed particle. because it's very negligible. So when it comes to the mass of an atom, or when we want to find the mass of an atom, what we take is only the particles, protons and neutrons, not electrons. Now, when we come on the relative concept, when we go back to the relative concept, which I explained before, so which element to be selected out of these elements as the relative mass unit or the mass unit? So scientists came up with different elements found in the modern periodic table, and they selected hydrogen, oxygen, and finally they selected the carbon. But there was a problem when you select the carbon atom, because you know that the carbon has isotopes. You know what is an isotope? Same element with different masses, mass numbers. So out of this, they selected carbon C12 isotope as the standard atom, atomic unit. To compare, we say that I said earlier that we can't measure the mass of elements, but we come up with a concept called relativity. So to compare the other elements, they have selected the model atom as the carbon. So out of the carbon isotopes, they selected carbon 612 isotope. Now, but they didn't select the mass of the carbon atom as the standard unit or the atomic unit. What they did was they divide this carbon atom by 12, because you know the carbon in the middle, we don't consider the electrons here, only the protons and neutrons. There are 12 particles are found in the middle of an atom. So this is contributory factor. These protons and neutrons represent the mass of an element or a matter. So now they divided into 12, and they took this one proton, we say for example proton or a neutron, as the atomic mass unit. To explain this further, I'm going to give an example with, like, take the carbon atom as a cake. So this is the carbon cake. Now I'm going to cut this cake into 12 pieces. So when you cut this into 12 or divide it by 12, you take the one piece here, right? So the one piece is said the atomic mass unit. Carbon cake එක අපි atom එක එක එකක් කියලා ගමු. අපි මේක පැහැදිලි කරගන්න. එතකොට carbon cake එක අරගෙන ඒකෙන් 12කට කපනවා cake කෑල්ල. එතකොට ඒකේ එන cake කෑල්ල තමයි එක cake කෑල්ල තමයි අපි කියන්නේ model cake එක. So we are going to compare this atomic mass unit with the other elements or compounds. So this atomic mass unit means, remember, that is 1/12 of the mass of the carbon. 1/12 of the mass of the carbon. Now, for example, we take an element where you don't know the mass of the atom. අපි කියමු මේක oxygen atom කියලා අපි නිකන් හිතාගමු. But we don't know the mass of the atom. Real mass, true mass. So now take this as a cake, the oxygen cake. And what is the model cake that we have took? Out of the carbon, only one piece. That is 1/12 of the model piece of the cake. How many pieces that you can cut on this oxygen cake or unknown cake? So for oxygen, they have found, right? When you මේ atomic mass unit එක බලාගෙන මේක කපලා බැලුවම ඒගොල්ලෝ හොයාගත්තා oxygen කැලි 16ක්. මේ oxygen atom එකේ you can cut it 16 pieces. මේ වගේ කැලි 16ක් කපන්න පුළුවන් කියලා හොයාගත්තා. So how many times the oxygen atom, for example, is larger than the standard unit, standard mass unit or atomic mass unit, that is the 1/12 of the mass of the carbon atom, 16 times. So this is called the relative atomic mass of oxygen. මෙන්න මෙහෙමයි relative or atomic mass එක අපි oxygen වල ගත්තේ. carbon cake එක අරගෙන බලනවා අර වගේ 12න් එකක්. carbon cake එක 12න් කපලා ඒකෙන් අර කෑල්ල වගේ one piece of cake වගේ oxygen atom එක ගත්තම කෑලි කීයක් කපන්න පුළුවන්. Same as this. So this is the concept they came up with. So they found it is 16. So this 16 is called the relative atomic mass. So there is no unit for this atomic mass. So similarly, you know what is a molecule. So molecules consist of two or more elements. They are consist of two or more elements. So carbon dioxide is a molecule. Now look at this. If they ask you to find out the relative molecular mass of carbon dioxide, So take the mass of the whole cake. This is cut to cake again, right? Take the mass of the whole cake and divide it by the standard cake piece. That is 1/12 of the carbon atom, the mass of it. So how do you find? So now they have found for the carbon dioxide cake. That is not a single cake. That is a molecule. That is, we have several layers of cake. So whatever the size of the cake, whatever they are single layered or many layers, we don't mind. We take this model cake piece, that is 1/12 of the carbon, and we check how many pieces that you can cut. So they have found carbon dioxide, you can cut 44 pieces, for example. So this is how they have developed the concept of relative atomic mass. So now, in your syllabus, they have given an equation to find the relative atomic mass and the relative molecular mass. So what is actually the equation to find out the relative atomic mass? Atomic mass, relative atomic mass. So now take the mass of any atom of the element and divide it by 1/12 of mass of carbon atom. Which carbon atom? The isotope 612. Take one carbon, mass of this one carbon, divide it into 12, and that is the model or the atomic mass unit. So out of it, you are going to see how many times larger, right? The mass is larger. So take the mass of an atom, divide it by 1/12 of the mass of carbon atom. That is 612 isotope. Similarly, you can find the relative molecular mass. So on the numerator, you write down the mass of a molecule, not the atom here, the mass of a molecule, and divide it by, and remember, divide it by the same atomic mass unit. Same thing, 1/12 of the mass of carbon atom, isotope 612 carbon. So there is an example here how to apply this equation when it comes to calculations. Yeah, before that, what is atomic mass unit? That is, atomic mass unit means 1/12 of the carbon. අපි අර carbon cake එක අරගෙන 12ට කපලා එක කෑල්ලක් තමයි අපි කිව්වේ. 1/12 of mass of this carbon atom is called atomic mass unit. This is the standard unit which we use to measure the relative atomic mass or the relative molecular mass. So don't take it as cake. So this is an example, right, that I have taken here to explain, right? So carbon atom, right, not carbon cake, right? Now, take a look at this calculation. Now they have asked to find out the relative atomic mass of sodium atom, where the mass of the sodium is given in grams. That is very tiny, very smaller, 10 to the power minus 23, right? And the mass of the carbon atom is given here, right? Now, how to apply this equation? So first of all, write the equation. So relative atomic mass of sodium is equal to the mass of the sodium. So what I have mentioned, I have written here the mass of the sodium. Mass of the sodium and divided by that 1/12 of the mass of the carbon atom. These are given, right? You don't want to remember anything, right? So now you do the calculation here. So 10 to the power minus 2, 1/12 of these, and you can cut off the 10 to the power minus 2, minus 23, minus 23 will be cut off, and the grams also will be cut off. And finally, when you simplify these, you will get the answer as 23. So you don't get such calculations for your O-level examinations because you can't do it. You need a logbook to do these calculations. But remember the application. How do you substitute the values? The substitution of the values are important here. මේක අර substitute කරන විදිය දැනගන්න. ඒක තමයි බලන්න. එතකොට අර පල්ලෙහාට දාන්න ඕනේ 1/12 of the mass of the carbon atom. That is the atomic mass unit. So whatever the unknown element එක නම් අපි atomic mass unit කියලා කිය relative atomic mass කියනවා molecule නම් ඒ molecule එකේ mass එක අරගෙන බෙදන්න. So relative molecular mass. Now relative molecular mass when a calculation is given now. So for the carbon dioxide, mass is given for the carbon dioxide is 7.31 into 10 to the power minus 23 grams. And then now we have to find out, this should be relative molecular mass. Atomic molecular mass of carbon dioxide. So there's a mistake here. So that is relative molecular mass of carbon dioxide, right? And then you get the values and substitute the values as the atomic mass unit, 1/12 of carbon atom, the carbon mass is given. So this is, when you calculate, you will get the final answer as 44. So this is relative molecular mass, not atomic mass, right? Molecular mass of carbon dioxide. So now, this is the very important part where the most of the questions arises from this part. So the relative atomic masses of elements will be given in your questions, in your examinations. So don't worry, you don't want to remember any of these relative atomic mass. So for example, we say relative atomic mass of nitrogen 14. 14 means, remember, අර cake piece කෑල්ල වගේ 1/12 එක වගේ nitrogen cake එකේ කෑලි 14ක් කපන්න පුළුවන්. And magnesium 24 means relative atomic mass. That means you can cut 24 pieces. Right? The cake name I'm explaining. This is for clarification, right? With example, I took the cake atom as a cake. So sulfur 32 means you can cut 32 pieces. This is not in grams, remember. We are just comparing. Relativity means that is what we say. Relatively how bigger or smaller. So now they will give each of these elements the relative atomic masses, and then they will ask you to find out the relative molecular mass. Atom එකේ mass එක දීලා අපිට කියනවා molecular mass එක හොයන්න කියලා. The molecular mass එක හොයන්න. So the molecules are given. For example, they are now in my tute, I have given these questions to find out the molecular mass of calcium carbonate, sodium hydroxide, glucose, potassium bicarbonate, and so on. So let's see one by one, how do you calculate the relative molecular mass when the relative atomic masses are given. Let's take a look at this. Calcium carbonate is a molecule. Now they have given calcium as 40. In the previous we learned they have given it 40 කියලා දීලා තියෙනවා මේකේ. මෙන්න මේ relative atomic masses ටික අපිට දීලා තියෙනවා. Now they have given it. Now we have to substitute the values, right? Now, so calcium carbonate is a molecule. Now you have to find out the relative molecular mass using the atomic masses. So calcium, the relative atomic mass is 40. How many calcium atoms are found in calcium carbonate? Only single atom is found. Only එකයි තියෙන calcium carbonate. එතකොට එකක් තියෙනකොට 1 times, so 40 pieces you can cut. And carbon, how many carbons are found in calcium carbonate? Ya පුතා බලන්න එකයි තියෙන්නේ, 1 carbon atom. So carbon 1 is, they have given the atomic mass as 12. So 12 into 1, so we have 12 pieces you can cut. If you look at the oxygen here, oxygen, there are 3 atoms are found in 1 calcium carbonate molecule. එක molecule එකක තියෙනවා calcium carbonate, එක molecule එකක oxygen 3ක් තියෙනවා. So 1 oxygen you can cut 16 pieces. So there are 3 oxygens. මේක තට්ටු කියන්නේ calcium තට්ටුවක් තියෙනවා, carbon තට්ටුවක් තියෙනවා, 3 oxygen තට්ටු. ඒ කියන්නේ තට්ටු පහක් තියෙනවා මේකේ, right? අපිට ඒක වැඩක් නැහැ. calcium cake එකේ කපන්න පුළුවන් කෑලි 40. Carbon cake එකේ 12, 12 pieces. In oxygen each 16, and there are 3 layers, so you get 48 pieces. So now add these all, you can cut 100 pieces here. So that means out of these 1/12 of carbon, the mass of it, and when you divide it by 12, you get the atomic mass unit. Out of it, you can have 100 times the calcium carbonate molecule. ඒ වගේ 100 times larger වෙනවා. So this is how you calculate the molecular relative molecular mass. So the relative molecular mass here is 100. And they have asked in the question molar mass. So remember, දැනට අපි මේක දාමු grams per mole. Relative atomic mass එක හරි relative molecular mass එක අරගෙන ඒකට we use a unit, grams per mole. Per mole you have 100 grams. I'll explain what is this unit is, the mole concept. After we learn the mole concept, you will understand the unit for the molar mass. Now you take the relative molecular mass, ඒකම අරගෙන නිකන් gram per mole කියලා just indicate, right? Just indicate කරන්න. Next, sodium hydroxide is a molecule. Now they have given sodium as 23, oxygen as 16, hydrogen as 1. Relative atomic masses are given. So you have only 1 sodium here, and you have 1 oxygen here, and you have 1 hydrogen here. So altogether you get 40 relative molecular mass. So the relative molecular mass of sodium hydroxide is 40, and the molar mass is same. You take the relative molecular mass and just add the unit grams per mole, gmol minus 1. And similarly, you can calculate these. So another example we take glucose C6H12 on O6. There are about how many atoms are found here in this one molecule? Carbon 6, and 12 into 6. Each carbon has 12 relative atomic mass, and 6 times 72. Hydrogen, there are 12 hydrogen atoms are there. So 1 into 12. And then there are 6 oxygen atoms are there. Then 16 into 6. Then when you add them all, you will get as 180 for the relative molecular mass of glucose. C6H12O6. And at the same time, you can show the molar mass as, take this relative molecular mass and put it as grams per mole. Similarly, potassium bicarbonate. Just go through it. So you can do these calculations by yourself. So the answers are here. You can check them. Right. So how do you calculate? Right. And then for the aluminium phosphate. Right. So the atomic masses are given. Phosphorus they have given 31, aluminium 27. There are 4 oxygen atoms are in one molecule of aluminium phosphate. So when you get the answer, you will get this 122 as the relative molecular mass. Ammonia is a gas, NH3, right? So again, so you get the value as 17. So please do these calculations by yourself. And again, hematite, you have heard this hematite, you will learn this on grade 10 students will learn later on. And the grade 11 students, they know what is Fe2O3 is hematite. So most of the time you get the calculations, mole calculation on this hematite. So remember how to calculate the relative molecular mass of hematite. So there are 2 iron atoms and 3 oxygen atoms, and you get here 160. So this is how you find the hematite. And similarly, you can find the methane, CH4. How do you get this? You can check the answers, right? And the carbon dioxide, right? And then we have given certain questions like this. So please practice and try to get these answers and check whether your answers are correct. So now we will come to another point, right? That is on a very important point. There's another special unit here, molecule. There is a special another molecule called urea. So this is a different case. You see the bracket in NH2, and again out of the bracket you have number 2. So now how do you find the relative molecular mass? Please work out on this. Try to get the answer, hold the video and try to get this. Carbon atomic mass is 12, oxygen 16, nitrogen 14, hydrogen 1. Now find out the relative molecular mass of this compound, please. So when you do the calculation, check this, your answer is correct. It should be 60. So remember, there is a nitrogen here. There are not only one nitrogen. So the bracket represent that belongs. These 2 belongs to both nitrogen and hydrogen. මේ bracket එකේ දාලා තියෙන එක nitrogen ටත් hydrogen දෙන්නටම පොදුයි කියලා මතක තියාගන්න. So there are 2 nitrogen atoms and 4 hydrogen atoms. 2 into 2 you get 4. So this is how you calculated the relative molecular mass of urea and molar mass. Right. So the next one, I'm going to explain you another concept. Look here. We know to find out the relative atomic mass and relative molecular mass. Still we don't know. We can't measure these elements or compounds. But we know the relative concept, that relative atomic masses, you can make it. That is not a gram, right? There is no unit for this relative atomic mass and relative molecular mass. Now, what I'm going to do is, so take the relative atomic mass and the relative molecular mass and in grams. Glucose wala 180 gatta, ekata grams dawa. Sodium atom එක ගත්තම 23, ekata grams dawa. So when you put it into grams, now you can measure. Then පුළුවන් අපිට measure කරගන්න. Relative atomic mass or the relative molecular mass is taken, you calculate it, and then take it in grams. Now put grams in. And now you count, you take that grams, you can measure now. Grams එක measure කරගන්න පුළුවන් and check how many number of atoms are found if it is relative atomic mass is given in grams, or the molecules, the number of molecules if the relative molecular mass is given. If you find this, you see here, you will get a constant number in any of, you say hydrogen ekite, 1 gram, you get this much of, you can see this much of 6022, 20 zeros. I don't know how to express this in kilos or millions or billions or trillions. I don't know. Thousands, a million, the billion, anyway. This is a huge number. Relative atomic mass or the relative molecular mass is taken in grams and you get this number of atoms or molecules. That is constant. That means if you take calcium as 40 atomic masses, take 40 into grams. 40 grams කරන්න ඒක ඇතුලේ තියෙනවා calcium atoms මෙන්න මෙච්චර ගන්න. 6022 20 zeros. And take oxygen atomic mass as 16 and make it into grams, you get 16 grams, and then count how many oxygen atoms are found in 16 grams. Again, you get the same number. And take water molecule, H2O is a molecule. in grams, that is 18 you will find, right? We have found it 18 grams. 18 grams වල H2O molecules කීයක් තියෙනවද කියලා බලන්න. relative molecular mass එක අරගෙන බලන්න එක grams කරලා molecules කීයක් තියෙනවද කියලා you find the same number. So this was found by Avogadro. So this number is found by Avogadro. So this is called the Avogadro constant. මෙන්න මේ number එකට තමයි Avogadro constant කියන්නේ. This number is only called as 1 mole. මෙන්න මේ number එකට තමයි කියන්නේ 1 mole කියලා. දැන් මම කියනවා අපිට මේක 1000ද millionද billionද trillionද we don't know to say. This total number we say 1 mole. So instead of writing this whole number, we can express in terms of mole, 1 mole. Or if you want to show the numbers in 10 to the powers, right? නැත්නම් මේ පොතේ ඉඩයයි මේක ලියන්න ගියොත් එහෙම, right? මේකේ ගණන් හදන්න ගියොත් we say 6.022 10 to the power 23. So මෙතනින් 3ක් පන්න ගත්තා. 6.02 3ක් පන්න ගන්න zeros 20ක් යනවා. 20 zeros. Right? And this is called the mole. So what is mole? Avogadro number. It's a number. What is the number? 6022. That is Avogadro constant. How do you find it? Take the relative atomic mass. In grams, you find this 1 mole. So further explanation, we'll do some calculations and you will understand. So what is the SI unit used to measure the amount of substances? So any of these substances, amount of matters, amount of substances. අපි කියනවා දැන් මෙතන pan කීයක් තියෙනවද? අපි කියනවා 10යි 2යි 20යි. 1000, million, trillion, right? That is not the amount of substances that we measure. The international standard unit is given to measure the amount of substance is moles. It is moles. Remember that. That count, huge number. So you can measure moles not only for the atoms and molecules, anything, any substances. We say I have moles, 2 moles of chocolates at my home. So 2 moles means 6022. That huge number. 2 times of it is found in my house. The chocolates. So mole is a measurement or unit used to count the atoms, because you know that atoms are found in huge numbers. So it is easy for us to use the mole concept when we calculate or count the number of atoms or molecules. Now, what is the Avogadro constant and its relationship with the moles? So you know that Avogadro constant means 1 mole. 1 mole. Avogadro constant. Can I 1 mole? තමයි අපි කියන්නේ Avogadro constant. What is the number? Huge number. 6022 and 220 zeros. So in simply we say 6.022 10 to the power 23. Right? And remember, don't get scared with mole, the word mole, right? Think mole when never make up dakala, very easy calculations, right? Mole concept kiwama. Make a hariyatama pahadili wuna nam, right? So I hope that you got the point here. Clear explanation is done here. So mole is a number. Don't worry. Not grams. It's a number or a count used to measure any substances. That is not a gram. It's a number. How many numbers are found? How many count, or we say the count, the mole. That is which number? If you take it into numbers, so 1 mole means 6.022 10 to the power 23. Now take a look at this. I explain. Take the relative atomic mass or relative molecular mass in grams. That is called 1 mole. අනේක අරගෙන grams වල අපි 24 3 grams එක ගත්තොත් එහෙම sodium වල ඒකේ තියෙනවා මෙච්චර count එකක්. So that is called 1 mole. Take this example. Take the sodium. Now we know that the atomic mass is 23 and take it in grams here. Take a grams kara. Now you can measure. So how many sodium atoms are found in these 23 grams? How many? This number 6.0. That means 6022 20 zeros. 6.022 10 to the power 23. So that is, this number is called 1 mole. අර number එක තමයි 1 mole කියන්නේ. එන එක mole එකක in 1 mole you get 23 grams of sodium atoms. 1 mole you have 23 grams of sodium. So that is called the molar mass. ඒකට තමයි molar mass කියන්නේ. එක mole එකක how many grams you have? 23. If you take 23 grams of sodium, it has 1 mole. For 1 mole you have 23 grams. So in 23 grams you have 6.022 10 to the power 23 sodium atoms. That means 1 mole. So this is the relationship between the relative atomic mass or the relative molecular mass and the mole and molar mass and the numbers. Make අපි calculations කරනකොට තව තේරෙනවා. So the molar mass means how many grams per mole. If you take sodium atom, in 1 mole you have 23 grams. That is the relative molecular mass or relative atomic mass. So in case of atoms, we take the relative atomic mass into grams, that is grams per mole. So I have explained this in sodium, and take a look at, again I'm going to explain 23 grams. You see, if you take 23 grams here, so you can't count it, right? We can't count how many sodium atoms are found. So this was done by an experiment by Avogadro. Make a experiment, right? So they have found in 23 grams, that means relative atomic mass of sodium. In 23 grams, if you want to count how many atoms are found in these 23 grams, it is found this much. That is 1 mole. Huge number. එහෙනම් relative atomic mass එක අරගෙන gram කරන්න ඒක තමයි 1 mole කියන්නේ. ඒක ඇතුලේ තමයි මෙච්චර count එකක් තියෙන්නේ. Avogadro constant එක 6.022 10 to the power 23. If we take we say for example oxygen. 16 is the relative atomic mass that will be given to you. Gram කරන්න 16 grams. In 16 grams, if you want to count like this, right? If you want to count like this, so you will get how many atoms of oxygen? 6022 20 zeros. That means 6.22 10 to the power 23. In simply we say this count is 1 mole. So in 23 grams of in oxygen, 16 grams of oxygen, you have 1 mole. So the molar mass of oxygen is 16 grams per mole. And similarly, carbon dioxide. Take the carbon dioxide. It's a molecule. It's a molecule. And its molecular mass, you know how to calculate. Each carbon has 12, oxygen has 16. 16 into 2, you get 32 plus 12, 44. And make it grams. 44 grams now. And මෙතන තියෙනවා 44 grams. Then count කරන්න පුතා carbon dioxide molecules කොච්චරක් තියෙනවද කියලා. Molecules are not atoms here. The molecules කොච්චරක් තියෙනවද කියලා. You have the 1 mole of it. So that is the molar mass of carbon dioxide, 44 grams per mole. Similarly, if you take glucose, we found that the relative molecular mass of glucose was 180. Put it in grams, you get 180 grams. 180 grams එක ගත්තා. ඒක අරගෙන ඒකට දානවා අපි දැන් කොච්චර glucose molecules තියෙනවද කියලා. When you count one by one molecules number, Avogadro number, 1 mole you will find. Right? Right. So now answer me this question. So there are carbon dioxide molecules. So you see CO2 is actually connected. One molecule is connected with 1 carbon and 2 oxygens. Right? Now can you tell me how many, it should be CO2 here. Number of carbon dioxide molecules, CO2, it should be CO2 here. Something wrong with it. And number of carbon atoms and number of oxygen atoms are found in this. Carbon dioxide කියලා නෝනේ CO2. මෙතන බලන්න molecules කීයක් තියෙනවද කියලා. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, around 16. How many carbon atoms are found? Calculate and see. Again 16, but when it comes to oxygen, in 1 molecule you have 2 oxygens here. So you get, when you count, you get the oxygen number, atoms are 32. Right? So what do you find here? So I'll show you a simple calculation here. In 44 grams of carbon dioxide, so we have, that is 1 mole. In 1 mole, you have this number of atoms, molecules. In 44 grams of carbon dioxide, you have the carbon atom or same as the carbon dioxide molecules. That is also same. But when it comes to oxygen atoms, the carbon dioxide molecule, ඇතුලේ carbon තියෙනවා මෙච්චර. Oxygen තියෙනවා ඒක double. Look at this calculation, it's double. If you look at the total number of atoms, I'm going to make a calculation again. If you take the total number of atoms, this is for example, right? You have how many total number? Right? 3 into how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, that is 48. Right? You have 48. එතකොට carbon තියෙනවා 12, oxygen තියෙනවා 32. එතකොට දෙකම එකතු කරාම තියෙනවා 48, but molecules තියෙන්නේ 16. So this is a very important concept. We'll do more calculation on it. You will understand. Right? So in 44 grams of carbon dioxide, you have 1 mole. That means this much of 1 mole of carbon dioxide molecules. In 44 grams of carbon dioxide, you have carbon atoms. Molecule is made out of atoms. So 1 carbon is there, 2 oxygen atoms are there in 1 molecule. So 1 mole you have 1 carbon atom. In 1 mole of carbon dioxide, you have 2 moles of oxygen atoms. ඒක නම් ඒක multiply කරනවා දෙකෙන් total atoms ගන්න හෙව්වොත් එම ඒකේ number එක ගත්තාම එකක 3ක් තියෙනවා නම් 3 into 1 mole or 6.22 10 to the power 23. Right. So remember, 1 mole of carbon dioxide molecule contains 1 mole of carbon atoms and 2 moles of oxygen atom, and the total numbers 3 moles. Atoms, 3 moles of atoms. Atoms, molecules, so in 1 molecule of carbon dioxide, molecule is made out of carbon and oxygen. You have 1 carbon and 2 oxygen atoms. So altogether you have 3 atoms. When it comes to atoms, 3. When it comes to molecule, 1 molecule. Right. How many moles of carbon dioxide found in 18 grams? Now you see, we know that how to find out the relative atomic molecular mass of carbon dioxide, that is 44. Put it in grams, that is 1 mole. So the molar mass of carbon dioxide is 44. That means in 1 mole you have 44 grams. Now my question is, how many moles of carbon dioxide found in 88 grams? In a mole like 44 grams, and 44 grams is 1 mole. 88 grams means you just simply divide it. The given mass is 88 grams. Divided by 44. Now you will get 2 moles. 1 mole 44 grams mean in 88 grams. It's a very simple calculation. You get 2 moles. So what I have done is given mass is divided by the molar mass. The given mass ka mama divide kara molar mass. So we can develop an equation to find the number of moles. Right? Take the mass as the numerator and divide it by the molar mass. So this is the equation. So remember, N equals simple M over capital M. Simple M is the given mass or the mass that you should find. Capital M means the molar mass. Molar mass means relative atomic mass or the relative molecular mass. ඒක තමයි දාන්නේ අපි මෙතන denominator වලට. Right. We'll now gradually progress into the calculations. So number of atoms and molecules equals number of moles into Avogadro number. 1 mole means this much, 6.022 10 to the power 23. And a number of moles දන්නවා නම් අපිට count එක ගන්න පුළුවන්. Atoms or number of atoms or molecules, just take the number of moles and multiply it by Avogadro number. ඒක අරගෙන Avogadro number එකේ multiply කරන්න. Right? එහෙමයි අපි number of atoms and molecules ඇවොත් කරන්නේ. Number of moles ඇවොත් take the grams and divide it by the molar mass. Molar mass means relative molecular mass. Atomic mass. Right? In grams per mole. So if they ask the number of atoms or molecules, not the moles, the mole number is multiplied by 6.022 10 to the power 23. Then you get the total count, total number of atoms or molecules. Now, let's take a look at this example. This is easy for you. Find the molar mass, number of moles and number of atoms found in 69 grams of sodium, 16 grams of sulfur and 5 grams of calcium. So they will give you the atomic masses. Sodium 23, sulfur 32, calcium 5. අපි දැන් මේක එක ගානක් මම explain කරන්න. මේක විදියටමයි same thing. It is easy for you to do the calculations, the rest of the calculations. Now see, sodium. Now we need to find out the number of moles, number of atoms found in 69 grams of sodium. So the relative atomic mass is given as 23. The first step of doing this calculation, write the relative atomic mass. That is 23, which is given. This is an atom. Now convert this atomic mass into molar mass. That is 23 grams per mole. In 1 mole, you have 23 grams. Now you have to find out how many moles of sodium are found in 69 grams. Then number of moles බලන්න මං කියවා equation එක දාන්න in over given mass over molar mass. And the equation එක දාන්න. Now you apply this equation. So the given mass is 69 grams and divided by the molar mass, which is 23. Now now you can calculate the number of moles found in 69 grams of sodium. That is 3 moles. 3 moles. Now, in 3 moles, in 1 mole, 1 mole is Avogadro constant, that is 6.022 10 to the power 23. In 3 moles, how many sodium atoms are found? Sodium gram හැටනමයක් අරගෙන measure කරන්න sodium atoms කීයක් තියෙනවද කියලා. You have 3 moles means, mole means a count. So I said, that is a count. So number of moles into Avogadro number, making multiply karana, you get number of atoms found in 69 grams of sodium is 3 into 6.022 10 to the power 23. So you don't want to solve this. You can keep it like this. You will get the marks. So I hope you understand. You understood this calculation. Similarly, we'll see. Now you know that in sodium 69 grams, take the 69 grams and count how many sodiums are found. This is not the only few numbers I have included here. It's a huge number. So in 69 grams, if you count one by one, how many sodiums are found? 3 moles. 3 moles means 3 into Avogadro number. That is this much of number. 3 into 6, 0, 2, 2, 20 zeros. This is 3 moles. When you make a concept, you will be able to do any of the questions. So you must understand this theory very well, right? Now we'll move on to the next calculation. Sulfur 16 grams. Now the sulfur 16 grams, that is an atom. So we need the atomic mass is given as 32. So maybe we have atomic masses, right? Now first step, take the relative atomic mass. This is an atom. So we take since it's an atom, we take the sulfur 32. Molar mass is 32 grams per mole. And you can apply the number of moles, this equation. The given mass is 16 grams. Given mass is and the molar mass is 32. So in 1 mole you have 32 grams. In 16 grams, how many moles? So this will be half. Put it in decimals, 0.5 moles. So how many sulfur atoms are found in 16 grams? 0.5 into the Avogadro number. Then multiply the Avogadro number. Maybe make calculation harder. Right, let's move on to the next calculation, that is 5 grams of calcium. So the relative atomic mass of calcium is given as 40 now. Then අපිට තියෙන්නේ අර වගේම relative atomic mass එක දාන්න 40. ඒ වගේම molar mass එක දාන්න 40 grams per mole. And then you find the number of moles using this equation, right? And then 5 over 40. So you get 0.125 moles. That is number of atoms. You can multiply it by Avogadro number. Number of atoms, number of moles. මේ බලන්න ප්‍රශ්නේ හොඳට කියව ගන්න. Number of moles නම් මෙච්චරයි. Number of moles කියන්නේ මෙන්න මේ equation එක දාන්න. Number of atoms හැර molecules හරි යවුවා නම් mole ගාන හොයලා ඉවර වෙලා multiply it by Avogadro constant. Right. So another interesting unit. This will cover whole of these calculations. Now they are asking find the number of moles. One question. Find the number of moles is one එක ප්‍රශ්නයක්. Number of molecules, another question. Number of oxygen atoms, third question. The final question is total number of atoms found in these given molecules. The masses are given 88 gram of carbon dioxide. අපි බලමු මේක මම ඔක්කොම කරන්න යන්නේ නැහැ. I'll explain one or two, then you can go ahead. You can do the rest of the calculations, right? And you can check the answers. I'll show you. Now, first take a look at this. 88 grams of carbon dioxide. Now, this is not atom, this is a molecule. So in one carbon dioxide, you have one carbon and oxygen, 2 oxygen atoms. One molecule of carbon dioxide, 1 carbon and 2 oxygen atoms. First step is, now it's not atom, it is not an atom, it is a molecule. Find the relative molecular mass. Now, make a calculate karna video. We have done this 44. And this is the molar mass. Now number of moles. The first question is number of moles. That is given mass is 88. Same, use this equation. That is mass over molar mass. Then dana number of moles 88. Then oka bedana puta 44 wali molar mass wali. Then you get 2 moles. Now you get 2 moles here. Now number of carbon dioxide molecules. Molecules gana wo balana 2 moles එක multiply කරන්න Avogadro number එකෙන්. So this is the second part of the question. So third part is very interesting. So now in 2 moles, in 88 grams of carbon dioxide, you have 2 moles of carbon dioxide. That means when it comes to count number of molecules, 2 moles no molecules make a set carbon dioxide set 2 times of Avogadro number, 2 moles. Now the next question is number of oxygen atoms. In 88 grams of carbon dioxide, now we found that you have 2 into 6.02 to 10 to the power 23 number of molecules. In one carbon dioxide molecule, you have 2 oxygen atoms. Atoms දෙකක් තියෙනවා. 2 atoms found in one molecule of carbon dioxide. එහෙනම් මේ carbon dioxide ඇතුළේම moles දෙකක් තියෙනකොට oxygen mole ඒකේ double වෙනවා. You get 2 times of oxygen atoms when it comes to atoms. Atoms double වෙනවා. එහෙනම් අපි දැන් බලමු. Number of oxygen atoms found in this. මෙන්න මේ molecule ගානම. Take the same molecule number of carbon dioxide which is found in 88 grams. 88 grams එක. දැන් ඒක double කරනවා because in one molecule you have 2 oxygen atoms. 2 times. So 2 into 2 is 4. This is the number of oxygen atoms. Similarly, if they ask the total number of atoms, we know one carbon dioxide molecule has 3 total atoms. In 88 grams, you have this much of 2 into 6.02 to 10 to the power 23 carbon dioxide molecules. Now you have to multiply that number into 3. So this is one molecule. In one molecule, you have 3 atoms. Now you have to multiply this into 3 to get the total number of atoms. So මේ pattern එක හොඳට බලා ගන්න. මේක තමයි ගොඩක් දුරට මේක දන්නවා කියන්නේ you can do any calculations in moles. So this is the concept. So understand the concept very well. So think of it. මම හදපු එක you think of it. and there are so many calculations are given, so you practice them, then easy. It's not a very difficult, it's not a difficult, actually this is very simple unit, right? If you are thorough with mathematics, it is easy. Now in 50 grams of calcium carbonate, this is another next question. So as I said, first calculate the RMM, or the relative molecular mass, that is 100, and the molar mass is 100 grams per mole, and the number of calcium carbonate molecules ganna puluwan using the same equation ekama danna. So the given mass is 50, molar mass is 100, so this is 0.5 moles of calcium carbonate molecules. How many molecules are found? 0.5 into Avogadro number. Now when it comes to the number of oxygen, we know that in one calcium carbonate you have 3 oxygen atoms. So in 50 grams you had this 0.5 into 6.02 to 10 to the power 23 molecules, calcium carbonate molecules. එක ඇතුලේ තියෙනවා oxygen 3. එතකොට multiply this by 3. The whole set, that means 0.5 into 6.02 to 10 to the power 23 should be multiplied by 3 here. මෙන්න 3ෙන් multiply කරන්න. Now you get the total number of oxygens. Total number of atoms. You count how many atoms are here. 1 calcium, 1 carbon, and 3 oxygen, and you have 5 total atoms. එහෙනම් අර 50 grams of calcium carbonate වල තියෙනවා පුතා this much of, that means 0.5 into 6.02 to 10 to the power 23 තියෙනවා calcium carbonate molecules. Then you multiply it by 5. So this is how you get the total number of atoms. So now you can do this calculation for all these calculations, right, which is given. So for glucose 360 grams, again you take the number of moles, right, and I'm showing you the calculation, right, 2 moles, and the glucose molecules 2 into 6.02 to 10 to the power 23. So in 360 grams of glucose you found 2 moles of glucose molecules are there, and there are 6 oxygen atoms in one molecule. So the number of molecules found in 360 grams, 2 into the Avogadro number. Now you have to multiply that number into 6. That is 12. And for the total numbers, in one glucose molecule you have 24 atoms totally. So now you have this much of molecules, and then you multiply by 24 into 2 into 6.02 to 10 to the power 23 and get 48. Around 48 into 6.02 to 10 to the power 23. Similarly, you can do it with all. This is hematite Fe2O3. So I'm showing you the calculations quickly, right? So same thing, same procedure. Follow the procedure and give the answers and check your answers. All these and check your answers whether you are correct or not. Oxygen atoms in a one molecule of Fe2O3 you have 0.7 into 6.02 to 10 to the power 23, and 3 oxygens are found in one Fe2O3. And then total number of atoms are, again you get 5 total atoms and multiplied by the number of molecules of Fe2O3, that is 360. Sorry, it should be 112. There is a mistake here again. 112 grams, not 360. It should be 112 grams. So likewise, you can calculate with 10 grams of sodium hydroxide, 360 grams of water molecule. These calculations are given. You can check your answers. 64 grams of oxygen molecule, and the urea, 15 grams of urea molecule. So number of moles, number of molecules, number of oxygen atoms, or number of hydrogen atoms, or whatever. The total number of atoms are calculated in this way, right? In glucose, 90 grams also given. Now, the last part of this theory is find the mass of the elements when the moles are given. Then make අනිත් පැත්ත. කලින් හැදුවේ අපි mass එක දීලා mole ගන්න හොයන්න. Now they are given with the number of moles to find out the mass. This is very simple. So this was the equation we used to find out the number of moles. Now the moles are given, molar mass we can find out, right? And then you simply cross multiply the number of moles and the molar mass, and you can get the M as the subject of the equation. So the mass can be mass can be calculated using the multiplication of number of moles into number of into mass, molar mass. So mass of a given number of moles you can calculate is multiply the given number of moles into molar mass. Now, for an example, to find out the moles, I said mass over molar mass. To find out the mass, moles into molar mass. So these are the two calculations that you can do. So find the mass of these elements. We find 5 moles of sodium. 5 moles of sodium namputa. The relative atomic mass is 23. So the molar mass is, Molar mass of sodium is 23. Number of moles are 5. So 5 into 23, you get 115 grams are found in 5 moles of sodium. And similarly, you can do this with water molecule. This water molecule. So water molecule molar mass is 18. So 2 moles multiply the number of moles, you get 36 grams. And for sulfur, 0.5 moles multiply, say, element, atom. So atomic mass is given as 32 multiplied by 0.5. Atomic masses pardon karane pa, it will be given to you. Mass of sodium hydroxide of 2.5 moles, and you must find out the number of molar mass of sodium hydroxide, that is relative molecular mass. Multiply karana, you will find the answers. Glucose in 0.24 moles. Moles of calcium carbonate 0.75 moles, and the mass of sodium sulfate in 0.1 moles multiplied by its relative molecular mass. So likewise, you can calculate for sodium bicarbonate as well, and its molecular mass is relative molecular mass is 84, given moles 0.0405. When you multiply this calculation, you get 4.2 grams. And mass of nitrogen again, 4 moles, you can calculate in this way. So this is about the mole concept. So I hope you understood very well, and thank you very much for watching this video. Wish you all the very best. Please share with your friends and subscribe the channel.